shallower in that part of tank. In that part of tank. There the ripples move. There the ripples move more slowly. There the ripples move more slowly because they drag they drag on the bottom of the tank. They drag on the bottom of the tank. Written? Now see what is happening. So basically this is a ripple tank. Suppose this is a ripple tank. So in this ripple tank, what I am doing, I am adding a glass plate. Now when you add a glass plate, so what happens, this water become less will be shallower as compared to the previous one. Previously the water level was like this. It is deep. This much depth it is having. Now what we are doing, I am immersing the glass plate so that to make the water shallower in this part. Now this is a glass, that means the medium is changing here. Initially the light will come from air, then in the water, then in the glass plate. That means in the glass. Clear? So this is how the we are changing the mediums. Write down. Up to here, there's no doubt. The imagination is in your mind. What we are doing, we are putting a glass plate in a ripple tank. Then write down. The ripples lag behind. The ripples lag behind the faster moving ripples. The faster moving ripples in the deeper water. In the deeper water. Full stop. Their direction of travel has changed. Their direction of travel has changed. In figure, it shows the same effect. It shows the same effect, but as a wavefront diagram. But as a wavefront diagram. On the left,
It shows the same.
but as a wavefront, diagram.
What's after?
Sorry.
What's after same? What's after
Same effect.
figure
Same
shows
effect.
effect? Okay.
Same effect, but as a wavefront diagram.
Thank you.
On the left, ripples are in. On the left, ripples are in deeper water. Deeper water. And moving fast. And moving fast. On the right, ripples are moving slowly. Ripples are moving slowly. The right hand end of a ripple, the right hand end of a ripple is the first part to enter the shallower water. To enter the shallower water. So it has spent longest moving at a slow speed. Hence the right hand end of each ripples.
Wait, can you repeat the sentence? Has spent
Spent longest moving spent longest moving at a slow speed. At a slow speed. At a slow speed. Hence the right hand end. Hence the right hand end. Hence the right hand end of each ripple lags behind further lags behind further. Now the diagram is like, now see, as I told you earlier, that refraction, what is happening? We are changing the medium, and due to change in medium, what is happening? The speed of that wave is changing. Yesterday I told you, as the medium is changing, speed of wave will be changing. So speed of light in air will be more than speed of light in water. So now here what we have done, we have make a wavefront diagram. This is a wavefront diagram. Now what it is showing? It is showing that these lines are in equidistant. Okay, I don't make the equidistant. These lines are equidistant to each other. So what here it is showing that when the water was deep, when the first case was there, when the water was deep enough, so at that time the ripples were moving fast. Why the ripples are moving fast? Because the speed of light in the uh, is in only one medium is not changing. That is why the speed of light will be more in the deeper water. That is the reason why the ripples are moving faster. Now once I immerse the glass plate, that means here medium is water, here medium is glass, so medium is changing. So this makes the change in the speed of light. So for that reason the speed of light decreases. Now speed of light decreases, which makes the ripple movement slower. Ripple becomes slow. Understand the difference? What is happening in first case? What is happening in first case? Directly we have the ripple tank, deeper water is there. So speed of light have only one medium, that is the water. So speed will be more. So ripple movement will be faster. Ripple will move fast. In second case, what we are doing? We are immersing a glass plate in the ripple tank. Now here water is filled, and as we fill the glass plate, so below is the complete vacuum. Nothing is below this. So now initially the light is coming, light reaches water, then it reaches glass, then it reaches vacuum. That means continuously medium is changing. That is why speed decreases. As the speed decreases, it makes the ripple movement slower. Clear? Every phenomena is clear? The difference between the two.
Can you just explain it one more time?
Okay. See, in first case, what we are doing, we are having the ripple tank. Complete ripple tank. Ripple tank, whenever I'm saying ripple tank, just imagine the bucket of water. Okay. So in first case, we are having a ripple tank. Now in ripple tank, light is coming like this. So initially light will coming from air, then it reaches water. That means only one medium changes there from air to water. So it has some speed of light in it. Suppose it is, suppose it's 3 into 10 to the power 8. Suppose, because only one medium changes there from air to water. This is the first case. Now in second case, what we are doing, we are putting a glass plate here. Now once we put the glass plate, so here it become vacuum. Vacuum means empty space, and the water will be filled upside of the glass plate. Clear? Now the light is coming. Light is coming from air, then it reaches water, then it reaches glass, then it reaches vacuum. That means three times the medium is changing from air to water, water to glass, and glass to vacuum. Now continuously the medium is changing. So this change the speed of light, and the speed of light decreases. Okay?
Okay.
Now once the speed of light decreases, so ripples speed becomes slow. The speed with which ripples are moving becomes slower. Here the ripple movement was fast. Understand the difference? What was in first case and what is in second case? Continuously the medium is changing, and due to medium change the speed of light decreases, and since the speed of light decreases, the movement of ripple becomes slower. Understand?
But in the first case, since it's only from air to water, instead of air to water to glass to vacuum, it's faster since it's only two mediums, right?
Yes, correct.
Wait, what if the mediums allow light to go faster? If there are like multiple mediums that allow the light to go, but another one with only one medium, but it allows the light to go slowly in it. Which
See,
one would be faster?
there is a medium. Maximum speed of light will be in air, as every medium has the slower speed of light. And as the medium is changing from air to something other, so the speed of light will decrease because maximum speed will be on air.
Mhm.
Understand?
I understand.
Now also, if whatever you are saying, suppose some new medium arises which has the greater speed, so you are saying that the speed of light, once it is changing, it become greater. Okay, I agree, but whenever there is a change in medium, so the ripple movement slow down.
Mhm.
Okay, ripple movement will be slower. Yeah.
Clear.
Okay, now write down the heading: explanation of reflection and refraction. Explanation of reflection and refraction. Now whatever glass plate we are putting, that is known also known as gap barrier. We are putting the glass plate, that is known as gap barrier. It is acting like a barrier and make a gap. Now write down: as ripples pass through a gap, as ripples pass through a gap in a barrier, in a barrier, they spread out, they spread out into the space beyond the barrier. They spread out into the space beyond the barrier, beyond the barrier. This is an example of, this is an example of, this is an example of phenomena called, phenomena called diffraction. Phenomena called diffraction. Spelling will be diffraction. diffraction. This is called diffraction. Now see, in the same previous example, when we are putting the glass plate, so imagine a situation when we put a glass plate and in glass plate there is a hole. Now what happens? When we are putting a glass plate in a ripple tank and in that glass plate there is a hole, then what happens? What you can see here, it is a water, complete water, light is coming. Now in that glass plate there is a defect, there is a crack or there is a hole. So what will happen? What you can see?
Is under it empty or is there just more glass below it? Like how far does the crack go?
See, you can see like this, ripples will come like this. Ripples will increase like this. The water start entering from this hole and it will be shown like this. It is like this.
And the larger the gap, the straighter the ripples will be, right?
Yes. Now this kind of phenomena in which the gap, there is a gap in the barrier. So from that the ripples are spreading out. It is coming out. It is like a spreading out. It is like this. They're continuously increasing in size. So this kind of phenomena, when there is a gap in the barrier, so that type of phenomena is known as diffraction. Okay, what this phenomena is known as? It is known as diffraction, in which the ripples are spreading out. Okay, so someone asked, what is diffraction? So diffraction is a phenomena in which there is a gap in a barrier and ripples are spreading out through that gap or through that space. Okay.
Can I just write it down?
Sorry.
Can I just write it down?
Yeah. The same thing you have written. I am explaining the same thing only.
Yeah, I just want to write it in a separate point, the exact definition of diffraction.
Okay. You want me to dictate?
Yes, please.
Okay. The phenomena in which the ripples are spreading out through the space or gap in a barrier is called diffraction. Then write down note. This effect, note point, this effect will be greater where the gap is narrower. Where the gap is narrower. That means when the space is narrow, like suppose this is the barrier and we have this much space. So diffraction will be more in this case. And suppose second case is, this is the first case, and second case is this much space is there. So here you will see less amount of diffraction. So diffraction in this case will be more. Why? Because the gap is narrower. Clear? Now write down. Change the para and write. Diffraction can also be seen in diffraction can also be seen in water waves in harbor. 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 The waves enter the waves enter the waves enter the harbor mouth harbor mouth and around corners spread around corners so that so that no part of the harbor no part of the harbor is entirely undisturbed is entirely undisturbed. Boats 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 bob up and down boats boats bob up and down on the diffracted waves on the diffracted diffracted waves written.
Mhm.
Now see, what is harbor? Have you seen harbor somewhere?
Yeah, it's the one where boats go to park.
Correct. So what happened in that harbor? The water waves come and struck the harbor. So what happened? There is a diffraction of waves there also. It is the like coast, sea coast or some coastal area. So it is like the end of the sea. So when the where the boats are tied up, when the water waves are coming and hitting that harbor, what happened? There is a diffracted waves, and due to the diffracted waves, if you have noticed, the boats move up and down. They are shaking. Why? This is because of the diffracted waves. Clear?
Mhm.
Can you imagine the situation?
Yes.
So next, write down, change the para again, and then write down some new example. Sound waves are sound wave readily diffracted diffracted as they pass through as they pass through as they pass through as they pass through doorways doorways and open windows. First off, we rely rely we rely on diffraction of sound every day. We rely on diffraction of sound every day to hear what is going on in the next room. What is going on in the next room? This supports the idea. This supports the idea that sound wave sound wave travels as a wave. Sound wave travels as a wave. Now here there is a new example. Like see, diffraction you are encountering every day. Like how? Suppose you are switching on the TV in your living room and you close all the doors and windows. So the person sitting in the room, like suppose you are attending your online classes in a room, so uh, very pale voice you will hear of television. And like suppose your sister come and open the doors. What happened? All the voice of the television enters your room. So this is how happening. This is through the diffraction of sound waves. Sound wave spreads like this, like the diagram what I have made. This hole here is the door or the window which is got opened by your sister. Now the sister is coming, opening the door. Now the door is acting like a gap in a barrier. Initially there was a barrier. Now the door is open. It make a gap in a barrier. Now all the sound wave that was in one of the room, suppose in the living room, enters through that gap and spread like this. So this is the diffraction of sound wave. So every day, like suppose your we rely on the diffraction of sound wave. How? Suppose your sister is calling to you from another room. So what happened? So if there is no barrier, if there is no door or window, whatever, so you won't be able to hear her voice. But since there is a door or window or some gap is there in the room, between the room, so that is why through diffraction that sound what your sister is making comes into your ear, and you can hear it. Understand?
Yes.
Now the diffraction is clear. Now whenever there is a diffraction, the sound wave spread like this. This is the wavefront diagram. We call it as wavefronts. It is spreading. This diagram shows that it is spreading.
Which diagram?
So sorry,
Which diagram?
in the screen
No, like one or two, or does it not matter?
you can't see the figure.
The one labeled 1 and 2, right?
Yeah. It is like this only. This hole is like the door. So it is spreading like this. The wave is spreading like this. This diagram shows that the waves are spreading. This is the diagram for wavefront. Whenever you have to show that something is spreading, you have to draw like this.
Okay, but if the hole or the door is opened up more, you'll hear it better, right? Or
Yes. So that is the diffraction. Now one more example. Write down, change the para and write. Light waves also diffracted. Light waves also diffracted when they pass through very tiny gaps. When they pass through very tiny gaps. You might notice that on a foggy night, on a foggy night, comma, street lamps, street lamps, car headlight, street lamp, car headlight appear to be surrounded by halo of light, halo of light. Full stop. This is because their light is diffracted by tiny droplets of water, tiny tiny droplets of water in the air. The same effect can also be the same effect can also be can also be seen seen during the daytime due to sun. Now see here, in this example I was giving you the sound wave diffraction, where the sound is coming from one of the room to the another. So that means the sound wave is getting diffracted through the door or the windows. Now here in this example, suppose there is some foggy night, where there's a very foggy night, very fog is there. So what happens, if you see the street light, so around the street light you see the halo effect of light. Now what is halo effect? So it is like, suppose this is the street light. Suppose this is the street light. So around this you see a circle kind of thing, and up to here you can see the light rays, and in that light rays you see the dust particles are moving. Have you ever seen?
Mhm.
Suppose you are driving, I don't know whether you are driving or not. Suppose you are driving, so around your headlight, some dust particles are seen like wandering here and there, and up to a certain distance. Suppose this is your this headlight. Now around this headlight, up to a certain distance, you see your headlight, and in that light you are seeing the dust particles are moving. So what is why you see this headlight up to only a certain distance? This is again due to diffraction. Now diffraction can be up to a certain distance only, and this diffraction is due to the tiny dust particles or the water droplets that is in the air. This tiny dust particle or the water droplets diffract the light wave coming from either the headlight or the street light. That means again the light wave is getting diffracted. Here in this case, dust particles and your water droplet act like a gap in a barrier.
Mm-hmm.
Clear?
Clear.
Now write down the one question. What is observed? What is observed when ripples? What is observed when ripples pass through a gap? When ripple pass through a gap in a barrier. In a barrier. Now try to answer this question.
Okay, so diffraction will take place and it will spread out through that barrier. And the larger the gap is, the straighter the waves. So if it's small, it will be more arced and circular, but the larger, the straighter.
Correct. Now next give heading diffraction in diffraction comma more or less. Diffraction more or less. Now overview of this I already give you. When will be the diffraction more and when it will be less?
The smaller, the more.
Yes, when the diffraction is less and when it will be more, I have given you in the note point. When the gap is narrower and wider, it is that only. When will be the diffraction will be more? Hello, Shama, can you hear me?
Yes, I can. I'm just writing it down.
Okay.
Written.
Okay, what you've written? What you've written?
wrote when the gap is smaller, the more diffraction will take place.
Wait a second, I will give you this thing. Na? The same topic we have today. Write down
Sorry?
the same thing I am going to discuss in detail. No need to write it by yourself. I will be giving you everything. So heading is diffraction, comma more or less. Under this, write down wave, waves are diffracted when waves are diffracted when they pass through a gap or around the edge of an obstacle around the edge of an obstacle the effect is biggest when the gap when the gap when the width of the gap is equal to the when the width of the gap is equal to the wavelength of ripples wavelength of ripples change the para the sound wave have wavelength the sound wave have wavelength the sound wave have wavelength between about 10 mm between about 10 mm and 10 meter and 10 meter. This is why